Good morning, grade 8. How are you doing today? Our lesson today is in geometry, chapter 6, lesson 3, conditions for parallelogram. Yesterday we studied the parallelogram. Here we're going to continue the parallelogram conditions. Our objective today is to prove that a given quadrilateral is a parallelogram. Our objective is to prove that the given quadrilateral is a parallelogram. Okay. Here the theorems, if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. If the two opposite sides are parallel and congruent, so this quadrilateral is a parallelogram. Another theorem, if both pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. As you see here, AB is equal to CD. One dash red, one red dash, and one red dash. BC and AD, they are congruent. As you see here, I have two blue dashes and two blue dashes, which means they are congruent. They are equal in length. Okay, the third theorem, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So like angle A and angle C, they are congruent. Angle B and angle D, they are congruent. So quadrilateral ABCD is a parallelogram. Today's lesson is opposite of lesson of yesterday. Is the opposite of lesson of yesterday. Well, lesson of yesterday, it was given that the shown figure is a parallelogram, and from the properties of the parallelogram you're going to answer. But here we have the opposite. We have some givens, and from the givens we want to prove that this quadrilateral given is a parallelogram. Okay, let's move to the second page. Okay, I have another conditions also. All the conditions we have studied yesterday. All the conditions we have studied yesterday. But as I told you, it is like inverse of operation. Instead of giving you this is a parallelogram, so you are going to solve according to its properties. No, you have the properties and you will prove that it is a parallelogram. So the fourth theorem, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Like you have here A and B. A is x, so B is 180 minus x. A is x, so D is 180 minus x. Because A and B, they are consecutive, so they are supplementary. A and D, they are consecutive, so they are supplementary. So it is given that, it is already given that x and B, A and B is x and 180 minus x. So A and B are supplementary. So ABCD is a quadrilateral, which is a parallelogram. ABCD is a parallelogram. It is given that A is x, D is 180 minus x. So A and D, they are consecutive angles and they are supplementary. So ABCD is a parallelogram. The fifth condition, if the diagonal of a quadrilateral bisect each other. If the diagonal of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. I have here two diagonals and they bisect each other. It is already given that they bisect each other. AZ is equal to CZ. BZ is equal to DZ. So they bisect each other. So now we can prove that ABCD is a parallelogram. Okay, example 1. Show that A, B, C, D is a parallelogram for x is equal to 7 and y is equal to 4. I want to prove that this quadrilateral is a parallelogram. How I'm going to prove it? I'm going to prove it by proving that the opposite sides are equal, or by proving that the opposite angles are congruent, or by proving that the two consecutive angles are equal to 180, or by proving that the two diagonals bisects each other. So which condition I'm going to prove by? According to the givens here. The givens here, they are giving you dimensions of sides. So I'm going through the first condition, or the second one, that the two opposite sides are congruent. So step 1, find BC and DA. BC and DA. Okay, BC is equal to x plus 14. And x here is given, it is equal to 7. So I'm going to substitute x by 7. So 7 plus 14 is equal to 21. Okay, here it's equal to 21. Let's do dA. dA is equal to 3x, and the value of x is 7, so let's substitute x by 7. So 3 multiplied by 7 is equal to 21. It's equal to 21. So now BC and DA, they are two opposite sides and they are equal to 21. This is step 1. Okay. Step 2, find A, B, and C, D. Because every two opposite sides, they are equal. So I have to prove that every two opposite sides, not only one pair, two pairs. So AB is equal to 5y minus 4. The value of y is 4, so I'm going to substitute y by 4. So 5 multiplied by 4 minus 4. 20 minus 4 is 16. Then go to CD. CD is 2y plus 8. Substitute y by 4. So 2 multiplied by 4 plus 8. So 8 plus 8 is equal to 16. So now I got the condition true. Every two opposite sides are congruent and are equal. Okay, so since BC is equal to DA and AB is equal to CD, so ABCD is a parallelogram by theorem 632. Okay, girls, here in B, show that parallelogram EFGH is a parallelogram for Z is equal to 11 and W is equal to 4.5. By which condition I'm going to use here? As we see here that they are showing angles. They are showing angles. So I'm going to see. To prove two conditions, the two opposite angles and the supplementary angles. Okay, the two opposite angles here are F and H that are given already. So I'm going to take F. F is equal to 9Z plus 19 degree. The value of Z is 11. So I'm going to substitute Z by 11. 9 multiplied by 11 plus 19 is equal to 180. So angle F is equal to 180. Okay, H is equal to 11Z minus 3. So I'm going to replace Z by 11. So 11 multiplied by 11 minus 3 is equal to 118. So now I proved the first one, that the two opposite angles or the two opposite angles are equal. Okay, then I want to prove also that the two consecutive angles are equal to 180, are supplementary. Let's take G, angle G. Angle G is equal to 14W minus 1. So 14W minus 1. So I'm going to multiply W by 4.5. So 14 multiplied by 4.5 minus 1 is equal to 62. If I add 62 to H, or if I add it to F, it should give me 180. Yes, when I add 118 to 62, it is equal to 180. So angle G is supplementary to both angle F and angle H. So now I proved that parallelogram EFGH is a parallelogram by theorem 634. So girls, I know all the properties from yesterday. I studied them well. Okay, now I'm going to do the opposite. I'm going to do the inverse. I'm going to prove that I have this property and I want to say that this is a parallelogram. Okay, girls? So, I have here number one. Let's solve number one together. Show that PQRS is a parallelogram for A is equal to 2.4 and B is equal to 9. As you see here, they gave us sides and they gave us angles. So let's prove by sides and by angles. We can do it. We know all the properties and all the conditions. So let's do it. According to the given, girls, according to the given, I will prove. What are the givens here? The givens here are sides here, and angles. Angle here and angle here. They didn't give it to me for fun. They didn't give it to me for fun. They give it to me to prove it. So I will prove it. Okay, girls? So let's try to prove it. So, first, I will talk about QP is equal to 7A, which is equal to 7 multiplied by the value of A, which is 2.4, which is equal to, let me do it here, 16.8. Okay, let's go to RS, its opposite side. RS is equal to 2A plus 12 is equal to 2 multiplied by its value, which is 2.4, the value of A, plus 12. 2 multiplied by 2.4 is equal to 4.8. 4.8 plus 12 is equal to 16.8. So now I proved that the sides are equal. So now QP is equal to RS. I put it here so it will be clear. Okay, girls, let's prove the angles. Angle, let me put any sign for it, like angle Q. This is not the correct symbol for the angle, but I don't have it on the keyboard. So I will give it this sign. Angle Q is equal to 10B minus 16 degree. So it is equal to 10 multiplied by 9 minus 60. So it is equal to 90 minus 60, which is equal to 74. Okay, girls, so angle Q is equal to 74. Let's see angle 4. Angle 4 should be 180 minus 74. Let's try to see. Okay, angle R is equal to 9B plus 25 is equal to 9 multiplied by 9 plus 25, which is equal to 81 plus 25. 81 plus 25 is equal to 106. Angle Q plus angle R is equal to 74 degree plus 106 degree. If I add them together, they are equal to 180. So now I proved that they are supplementary. So I proved that the two consecutive angles, that they are Q and R, they are supplementary. And I proved that the two opposite sides, Q, P, and R, S, they are congruent. Got it, girls? Okay. So nice to talk to myself. Okay. Let's go to the other page. Yeah, here I got a chat. Somebody talk to me. Yes, Mice. Thank you so much for interacting. Thank you so much. Okay, Mice. Let's go to the second page. I want to erase first. Wait, I'm waiting for the reply of the program to erase. There is a delay in responding here from the program, so please wait. Yes. Okay. So, here. Applying conditions for parallelograms. Determine if each quadrilateral must be a parallelogram. Justify your answer. As you see here in the first quadrilateral in A, I have what is given, only what is given. I have two opposite sides that they are equal and two opposite sides that they are parallel. But according to the properties and conditions of the parallelogram, every two opposite sides must be congruent and must be parallel. But I have here what? I have here only one pair that is congruent and only one pair that is parallel. So what is the reason here? No, it is not a parallelogram because one pair of opposite sides are parallel. A different pair of opposite sides are congruent. The conditions for a parallelogram are not met. You see, girls? Because you can answer quickly. Yes, I have here opposite sides. I have here parallel sides. Yes, it is a parallelogram. No. You must get two pairs of parallel sides and you must get two pairs of congruent angles. For example, you must get like this. You see here, now I got two pairs, the red one and the blue one. And I also must have like this. If I have like this, so of course it is a parallelogram, because every two opposite sides are parallel and every two opposite sides are congruent. So I have two pairs of parallel sides and two pairs of congruent sides. So the conditions here are not met. Let me see here B. Here I have diagonals, and the diagonals bisects each other. How do I know? By the equal sign of the sides that I have. Yes, the diagonals bisect each other. By the theorem 635, the quadrilateral is a parallelogram. Let's see this one. Determine if each quadrilateral must be a parallelogram. Justify your answer. Okay, first I will take 2B. 2B. Every two consecutive sides are equal? No, it is wrong. It must be every two opposite sides are equal. If you see here this one, it should be equal to this one, but it is not. It is equal to this one, and it is totally wrong. So, yes, mice, your answers are correct. Excellent, mice. So, 2B is not. I'm waiting, girls. Yes, it's coming here. 2B is not. No pairs of because the pairs of consecutive sides are congruent. No, I want the opposite sides. What about here? 2A. What about 2A? Okay, yes. Why? Because the diagonal of the quadrilateral here that I have forms two supplementary angles of one here. According to, I will try to explain it for you here. I will try to open, just give me 1 minute. I will try one option. If it works, I will do it. If it didn't work, I will try to continue explaining. Just give me 1 minute. But I didn't work, so I will complete like this. Okay, I will try to explain it for you. Okay, here I have a diagonal. The diagonal of the quadrilateral here, this one, this diagonals forms two similar triangles, this one and this one. So this diagonal forms two similar triangles and forms also two similar angles of triangle 1, and which are two similar angles for triangle 2. If I will say that this is triangle 1 and this is triangle 2. This diagonals makes two triangles similar. So since they are similar, so this angle is similar to this angle, and this angle, this one, is similar to this one, and this one is similar to this one. So the third pair of the angles are also similar by the third angle theorem. So both pairs of the opposite angles of the quadrilateral are equal. Look, girls, this one is equal to this one, and this one is equal to this one by the third angle theorem. So this one is also equal to this one. So since this part is equal to this part and this part is equal to this part, so the whole part here is equal to the whole part here, and this part is of course the angle. So now I got that the two opposite angles are congruent. Girls, do you want me to explain it again, or you got it? You got it, girls? Okay. I got a question here. I got it. Okay, thank you, mice. Okay. I have a problem here in the coordinate plane showing that quadrilateral ABCD show that the quadrilateral ABCD is a parallelogram by using the given definition or theorem. Before I want to do this, I want to remind you that the slope, how I can get the slope? Who will remind me? Who will remind me? Okay, change of y over change of x. Let me draw it better because okay, what else I want to tell you? How I can get dimension of a side using a coordinate when I am graphing and I want to get a dimension of a side using its ordered pair. How I can get the dimension? There were a theorem or a rule used to get the dimension of a side. Okay, if for example, if I want to get AB or any side, I will write first here x, for example, or a side, whatever it is equal to let me write it like this. This program is a little bit hard in math because I don't find easily the mathematical equations. X2 minus X1 squared plus Y2 minus Y1 squared. Any measure of any side, I can get it by this rule. Okay, so I'm going to use the two rules here. So I want to prove that this parallelogram that is drawn here in the coordinate plane is this quadrilateral is a parallelogram. So first, find the slopes of both pairs of opposite sides. If the slope of every two opposite side is the same, so it is a parallelogram. So slope of A, B, slope of A, B. So I'm going to use A, B, point A and point B. Slope is change in A over change in Y over change in X. Change in Y means Y2 minus Y1 over X2 minus X1. So Y2 here, AB. So I will start by B because A is 1 and B is 2. So it is 7 minus 2. This is Y2 and this is Y1. This is X1 and this is X2. So Y2 minus 1 is 7 minus 2. X2 minus X1 minus 2 minus 3. So it is minus 2 plus 3. So it's 5 over 1, which is 1. Slope of CD. C and D. Okay, so I'm going to use the ordered pair C and D. So Y2 minus 1, Y1 minus 1. Minus 4, it is minus 5. And X2 minus X1, 1. Minus 2. It is minus 1, so negative will cancel the negative, so it will be 5. So now I got the slope of the two opposite sides, A, B, and C, D. It is equal to 5. Let me get the slope of BC and AD. BC is what? For BC, I will use here I will use here BC. So y2 minus y1, 4 minus 7 is minus 3. 2 minus minus 2, so it is 2 plus 2, which is 4. So the slope here is negative 3 over 4. I want to get dA, opposite of BC. So dA, so I'm going to use here the 2 points, which is D and A, the ordered pair of A and the ordered pair of D. So it is D, A, D, A. So D is 1 and A is 2. So y2 here, it is 2 minus minus 1. So it is 2 plus 1, so it is 3. So y2, x2 minus x1 minus 3 minus 1, so it is minus 4. So I got here the same slope. So when the slope of the two opposite sides are the same, so I got, so when the slope of the two opposite sides are the same, so this quadrilateral is a parallelogram. Again, when I have a parallelogram in a coordinate plane, I will not apply the conditions and the properties that I have studied before. So what I'm going to do, I have to prove it using slope. Using slope. How I will get the slope? I will get the slope by change of y over change of x. Change of y means y2 minus y1 over x2 minus x1. y2 and y1 refers to the ordered pair of the side that I am choosing. So I will choose every two opposite sides, A, B, and C, D. And please make sure to choose the correct order of the sides. So when you are calculating the slope, you will calculate it correctly because you have negative signs. So you choose to take A, B, and C, D. A, B, and C, D. So then you choose to take B, C, and D, A. DA is different than AD because changing the numbers will change the signs. Okay, girls, I don't have time. 3 minutes are left, or I can say it quickly. Say this one. Find the slope and length of one pair of opposite sides. The slope, I will not explain it. I will explain they want the length of one pair of opposite sides. They want to get GH. For example, it's GH. I will use this rule, x squared x1 minus x2 minus x1 all squared plus y2 minus y1 all squared. It's not squared, it is x2 minus x1. I should write it down so you will not get confused. So GH. So I'm going to use the ordered pair for G and H. Okay, x2 minus x1. x2 is 4, x1 is minus 2. So x2 minus x1 all squared plus y2 minus y1, which is 3 minus 2, all squared. So GH is the square root of 37. JF, so I'm going to use the ordered pair of J and F. J and F. So x2 minus x1. x2 is negative 4 and x1 is 2. So x2, which is minus 4 minus minus 2 squared plus x2, y2 minus y1, y2 is minus 2 minus minus 1 all squared. So it is equal to square root of 37. So here when I got the slope of the two opposite sides, it is the same, and the measure of the two opposite sides, it is the same, so it is a parallelogram. So it is another kind of proving that this figure is a parallelogram. Thank you, girls, so much for listening. And please, girls, I want here to change this one. It is written x2, it's written down. It's better to write it down. It's x1 and y2 minus y1 plus. They are all squared. It's better to write it like this, girls. and the slope is y2 minus y1 over